This video lesson will teach you to recall and use the formula for the Pythagorean theorem. Understand that the Pythagorean theorem is one application of the law of cosines, and connect the Pythagorean theorem to its converse. Let's start. What is the converse of the Pythagorean theorem? The Pythagorean theorem allows you to find the length of any side of a right triangle if you know the lengths of the other two sides. It can be viewed in another way, as the Pythagorean Theorem Converse, to determine if a given triangle is a right triangle just by knowing the lengths of its three sides. To understand the converse of the Pythagorean theorem, you need to know and recall the Pythagorean theorem itself. A squared plus b squared equals c squared. This formula works for any right triangle, ABC, where A and B are legs and C is the hypotenuse. The theorem works for all right triangles, so if you know any two lengths, say A and C, you can find the unknown length, B. That is a useful application of the Pythagorean theorem. Before we leap ahead, let's make sure we see the special application of the law of cosines in the Pythagorean theorem. First, here is the law of cosines for triangle ABC, where A and B are legs and C is the hypotenuse, with angle C, the right angle, opposite the hypotenuse. We can simplify this to a squared plus b squared minus 2ab times the cosine of angle C equals c squared. The cosine of 90 degrees is 0, which leaves you with 2ab times 0. So the entire expression 2ab times the cosine of angle C equals 0, and can be removed, leaving just the Pythagorean theorem like this. Now let's take another look at the Pythagorean theorem converse. Suppose, though, we start at the other end. We have three sides, A, B, and C, but are not certain triangle ABC is a right triangle. In that case, we can apply the Pythagorean theorem converse, which states, if the square of one side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. Suppose you were given the lengths of three sides of a triangle and asked to determine if it is a right triangle. A common reason for this might be in architecture or in engineering, like getting the correct length of guy wires bracing an important bridge. Right angles in engineering are very strong. You know the three sides, legs A and B and hypotenuse C, are as follows. A equals 56, B equals 192, C equals 200. If a squared plus b squared equals c squared, then the triangle has to be a right triangle and the guy wires have to be the perfect and safe length to hold up the bridge. So, let's put the three lengths into the Pythagorean theorem formula. Multiply each number times itself. Then we add. What a relief! The guy wires are all the correct length to keep the bridge at a safe, sturdy right angle. Lesson summary. Today we reviewed what the Pythagorean theorem is and why it is useful, how to write and use the formula for the Pythagorean theorem, and learned how the Pythagorean theorem is one application of the law of cosines. You also learned what the Pythagorean theorem converse is, namely, any triangle in which the square of the longest side of a triangle is equal to the sum of the squares of the other two sides must be a right triangle.